Okay, welcome to section 13.4, page 2, number 8. So let's read the problem. A card is drawn from a standard 52 card deck. You pay $3 to play the game, which must be subtracted from your winnings. If an ace is drawn, you win $50. Otherwise, you win nothing. Calculate your expected value. Is the game fair? Okay, so when we play the game, how much are we expected to win or lose? So remember, the formula for expected value is, here it is, down here at the bottom. E, we're going to multiply the outcome by its probability. All right, so with this one here, we're going to talk about what our outcomes are. So we could either win or lose. So let's write down win first and talk about what it means to win. So here's our outcome. Okay, there we go. Now we can see it. All right, so if we're going to win, what does that mean? We're winning if we drew an ace. So we'll say card drawn. So that would be an ace. Okay, so what is the other possibility? We lose. And what will we draw then? Not ace, not an ace. All right, so now to figure out our x is, they're asking us the expected value. So they want to know how much you win or lose. So here they want to know expected amount to win or lose. All right, so how much are we going to win or lose? That's what X is, the amount to win or lose. So if we get an ace, what are we going to win? We're going to win $50. But is that really how much we won? We paid $3 to play the game. So in fairness, we didn't really win $50. We won how much? $47, because it costs $3 to play the game. So we're going to say that we get 50. Let's get rid of that X. We need some room here. We're going to say 50 minus 3, and that is equal to 47. That's our X. Okay? So that's how much we win. How about how much do we lose? Well, they say we win nothing if we lose, but we really did lose something. We lost the $3 that it cost to play the game. So we win nothing, but we paid $3, which means that really we lost $3. Okay, so that's our X. So if we think back to the formula, it was E equals X times P. So now we need our probabilities. Let's write down what our probabilities are. Well, we have to think, what would it mean, or what's the probability of drawing an ace? Well, let's look at our deck of cards. What do we have here? When I look at our deck of cards, here are aces. How many do we have? 1, 2, 3, 4, one of each suit out of the total number of cards, which we know to be 52. So probability of getting an ace here, that's equal to the number of aces over the total number of cards. Okay, so we said there were 4 aces out of 52 cards. So that's our answer there, 4 out of 52. That's our probability. Okay, so now how about if we lose? What's the probability of drawing not an ace? Well, the probability of not an ace would be the number of not aces, right, over total number of cards. All right, so how many are not aces? Well, if we look at our deck of cards again, everything except for this first one, so everything else, which would be 52 minus the 4, or 48. So we can say 52 minus 4 over 52, or 48 over 52. So 48 over 52. Should have left a little bit more room there. All right, well, now we're ready to calculate E. So E is equal to X times p of x. So we have how many different x's? 2. So we're going to say x sub 1 times p sub 1 plus x sub 2 times p sub 2. So let's go ahead and make that column x times p. And what are we going to get? We're going to get 47 times 4 over 52. And here we're going to get negative 3 times 48 over 52. And we add those two together. So here we're going to say 47 times 4 over 52 plus, well, I could have said just minus, but I don't know. We'll go ahead with that. Okay, so that's what we get. Now it's time to bring out our calculator. So let's see here. Make sure you can see that okay. All right, so we're doing 47. Well, you got to turn it on first. Okay, 47 times parentheses 4 divided by 52, close the parentheses, plus, now here, start the parentheses up. Make sure you do a negative, not a minus, but a negative 3, and then times parentheses 48 divided by 52, close the parentheses, equals. Okay, so what do we end up with there? We end up with 0.846. So 0.846, it keeps going, 1, 5, on forever. Okay, so that's what we get there. All right, now we need to think about what it is that we found. This is the expected value. Well, we're talking about dollars and cents, right? Here we expected to win $47, lose $3. So this is dollar amount, okay? So we want to make it into a dollar amount. Well, we've got to round it then. Right here, we're going to make 2 decimal places. So what happens when we do this? Well, we bump that up. Since it's a 6, it gets bumped up, and we're talking about 85 cents. So here's the expected value. So let's go ahead and write in words what it is we found. We expect to win. Why win? Because it's positive. 85 cents. Okay, so is the game fair? Well, we talked about whether or not a game was fair based on its expected value. If the expected value is 0, the game is fair. You're not expected to win or lose. That makes it fair. But we're expected to win, so it's not a fair game. So no, the game is not fair since E is not equal to 0. Okay, so that answers the question. All right, that concludes this video. You'll go to the next video to see problem number 9.